Okay, we're good. Yeah.
There.
Okay, well, thanks a lot for, welcome everybody. Thanks a lot for coming. My name is Mark Morsher, ECE, Electrical Engineering graduate from 1989. So I've been coordinating these types of alumni awareness engagement meetups for 2 years now, working with Joel and Carol and Ryan in the department. One of the things that I'd really like to accomplish is to expose our alumni, especially those like me from 25 plus years ago, to what's going on in the department right now and what the opportunities are that students have and research opportunities and the new labs and all the different type of technologies we're working on. So much has changed since I have been in school. It's amazing what opportunities are available, and this is one of them, humanitarian engineering, that Joel pointed me to. And back in the 80s, there were maybe little projects here and there, but nothing with this much emphasis and focus. So I thought this would be a great topic for alumni, so that we can go ahead and see what's available, and then especially if there's any opportunities where alumni can help out, because we're always looking for that type of level of hands-on engagement, so people can really get the feel and texture of what's going on and seeing the great things that our students and professors are doing. So this is our first time using Carbon Connect, so we actually have David Bradway joining us, and then potentially a couple others. And we're also recording it, so that way we can go ahead and take this information and store it and broadcast it out so other people can go ahead and get the information that we're going to present. So we're lucky and fortunate to have Kevin Passino, who's the director of the Humanitarian Engineering Center, here to present to us, kind of the history of what's going on and the type of projects and opportunities that are there and how alumni can help out. And then we also have Mary Shear here as one of the key students that have been spearheading a lot of the projects here within the center to kind of give her experience of what she's gone through and how it's made a difference for her. So go ahead and open it up to Kevin.
Thank you. Thanks, Mark. Thanks for having us. I guess I want to start with history. In fact, the earliest history of humanitarian engineering in Ohio State is apparently with Professor Herman Weed. Okay, this went back pre-1980. We have, in fact, in the audience, one of his graduate students who's began work with him, Roger Zwanzak, and I'm sorry I mispronounced that slightly, but I'm getting better at it over the years. I can spell it though. Professor Weed worked on Project Hope and involved Roger and others, I assume, in that activity. But since then, there's been other people in the College of Engineering, Denny Gunther over in mechanical engineering, Dave Dickinson, Don Costin, who I just saw earlier today, had done quite a bit of work. So these are in the years sort of preceding, let's say preceding 2004. ECOS, Mary's here to talk about ECOS. I'm not going to talk about ECOS, I'll let her do that. Formed in January of 2004. And then by 2005, ECOS led a trip to Montaña de Luz HIV/AIDS orphanage in Honduras. Okay, and Roger was there, as was I, and I think that's all the people in the room. But we have a person that was on the trip that's on remotely, and that's David Bradway. Okay, so he was heavily involved too. So we have a sizable alumni, and what happened is between 2004 and 2014, those 10 years, we had phenomenal growth. We literally have hundreds of students that are involved in this program. We don't have an accurate count, but we send over 100 students abroad every year to do humanitarian engineering field work, and I'll talk about that in just a minute. When we got to 2014, that's when the college approved the Humanitarian Engineering Center as an official college center then. So where do I flip? Okay, so this is our current status of what we are. So let me first talk about in here. In the standard university program, we have research in both undergraduate and the graduate level, and with a variety of faculty involved in that. In education, we have courses. We have a humanitarian engineering minor that with 15 credit hours, you get a minor in this field. And any student in engineering can get that. We have projects that are both domestic and international. I'm going to refer in just a minute to some of the people in the room because several people in the room actually have run those programs. Okay, we have a Humanitarian Engineering Scholars Program, which is a living learning community. The students live together in a dorm for the first year. Okay, this is sizable. This is a couple hundred students involved in this program. I think right now it's right around 200 that are in it at any one particular time. In terms of engineering student service organizations, we have ECOS, which Mary will talk about, the Engineers for Community Service. There's also, however, Engineers Without Borders and other organizations. There's all told, there's 8 student organizations in College of Engineering associated with service of some sort. So the center is this, plus these programs that run for engineering field work. Okay, so I'm going to just start and go around here. There's India. Okay, this is run for like 4 years. There's a new program in Tanzania. There's a program in Ghana. And what I'm going to do is stop here. If you don't mind, Roger, I'd like to ask you to explain what's going to happen in Ghana this coming year, because Roger's running that program.
Well, these programs are, what I call international engineering service learning. So it's a service learning, educational model, and the students are in the semester in the fall, and then they travel 2 weeks in the December, January period, the winter break. And this year they're working on a couple of water projects, water purification, water filters, one for a family and one for a large village. So there's 2 different sizes and perhaps 2 different types of technologies. We're doing a bio gas generator out of a latrine. And that biogas would be used for cooking. This is a plan for cooking. And we're also doing a solar, what we call solar kiosk, which is meant for areas that have no electricity. Everybody has cell phones, a way of charging their cell phones and actually paying, so it's a pay-to-play type of project. So it's version 1 of that project.
Okay, thank you. I'm going to come back to you in a little bit. Then there's a program in South Africa. There's programs in the United States, part of what Mary will talk about. I'm going to ask if Professor Anderson and I do the Columbia program together in last spring break. Could you describe briefly what?
Oh, it was awesome. So we were asked to help develop low-cost labs for the universities there because they have to train their students to be engineers, but it's too expensive to have labs, so they needed some way that they could get hands-on experience. So we set teams of students to come up with low-cost labs in the university, and then a second component was we developed low-cost outreach things that we went and did in some schools there with middle school and high school kids, and we had a great time.
Okay, thank you. I'm going to come back to you, Roger. In the Honduras, there's traditionally been 2 main programs in the Honduras. The one I mentioned before that David Bradway had been with was the program at Montón de Luz out in the middle of Honduras. But there's also a program in Choluteca. Could you discuss the Choluteca program briefly?
Well, it's again the same educational model. It's a 2-week trip during Maymester, and the semester is spring semester. Again, we have students that will work with. We have it's OSU alumni missionaries. They've been there for 30 years, so it's a real good communications with our partners. And they are doing things in the community. We have done things like solar. I mean, we put solar into a family of 5. We have done things like some biomedical projects, like for instance, a manually powered, foot-powered nebulizer for people who don't have electricity, but they can still. So it's made of a bicycle pump and a soccer ball. And we did that during the World Cup, of course. We had to use the soccer ball. And these same kinds of projects. We've done water projects. We've done other things that are biomedical, insulin cooling, some internet type of things where we can manage a diabetic in a village and transmit that information to a computer in a hospital and see how they're doing with their diabetes and so forth. So many other projects I can continue on.
Thank you. If you have more questions about any of these projects, you can talk to Roger afterwards, for instance. There's a program in Guatemala. I'll go on, skip over that, Reese, and talk about program in Paraguay that ran this summer. The Paraguay program had a short course on humanitarian engineering. It was done in Spanish. It was by two of my PhD students, Isa Fernandez and Hugo Gonzalez. Hugo is from Paraguay, and he was instrumental in really running this whole program. We also did STEM education, Arduino programming for disadvantaged children in high schools, which went really well. And then we also worked with what an indigenous community called the Tobacom, which is a community of several thousand people that are very low income, very difficult social conditions. We there built a cook stove and put in a kitchen on a young family's home with their help. We got lots of their help. Ryan put together an announcement on that, so there's more details to appear in there. Okay, Roger, we're back to you again. So Roger's heavily engaged. I was really happy to see him show up tonight. So you just, I know Haiti program has now been discontinued, but it ran for a number of years. So you briefly say what happened in Haiti?
Well, that one was really started very similar to actually the way the Montana to Luz Haiti. It really came from a student organization, not ECOS. It was solar education and outreach. They're interested in, not surprisingly, solar education and outreach. And what we've done in Haiti, what they've done for 6 years, I've done for 3, is install solar electric systems in clinics, in schools. We just finished a 3-year project that I've been involved in a school in Mackay. It was a 2.6 kilowatt system in a village that has no electricity, except for now the solar, of course.
Great, thanks. So the 2 flags up in here, you probably know, are Dominican Republic and El Salvador. Those are past programs, okay, that ran. So you can see what we're trying to do here at our core of our program is an educational program. We're an educational institution, of course, that's what our goal is. What we do is we have our coursework, local projects, and then we reach out to all these countries and send students to countries and do engineering field work on the ground. This is a pretty transformative experience for our students. They come back and they say, wow, their eyes are open. And it's not just that their eyes are open to the cultural differences, or the differences in food or the languages, the customs. It's the engineering field work, because what they find is they find, oh my goodness, when you really go out to do it, and you are put in a situation where there's lots of surprises. I mean, anybody that's really implemented something as an engineer knows there's always surprises. But when you're in these settings, there are always big surprises. And so learning to cope with that, I think, is very engaging experience for our students. It really does a lot. If you were to ask me what the alumni could do in this realm, there's nothing to say the alumni couldn't travel. That has happened in the past with some of the EWB people and gone with student groups. That's a pretty heavy time commitment, because to be able to travel, you need to be engaged in the pre-travel educational experience to some extent, or you won't really be a part of the team, okay? So that's one way of getting engaged like that. Another way is financially. I'm not afraid to say it. I mean, our smallest financial need is we need to be able to take care of the following problem. I can tell you, I don't know how many times, I haven't counted them, but a number of times, students walk in my office and say, I want to go to Honduras. I want to go to whatever these countries. I want to be a part of this. I don't have the money, period. It costs a student it depends on which of these places you go to. I mean, the further away the airline ticket costs the most. Usually the largest cost is the ticket. Second largest cost is wherever you're staying, typically. You know, I think some of these trips are as low as $1,700. Some are $2,500 or $3,000. So let's just say it's $2,000, roughly. And I don't believe for our students, I would never hand any student walking in my office the full cost of the trip. I think that'd be a bad policy. They got to have skin in the game, and they can get it by doing their own fundraising from relatives and family. Okay, so if someone wants to help out financially, you know, even covering the cost of the ticket at $1,000, let's say, it was a huge something would be greatly appreciated by students, and would be faculty could vet and make sure it's going to the right sort of person. Okay.
Do you have any scholarship funds established for?
Nope. We're looking for them. That's exactly what we're trying to work with ECE, Katie Cohen, ECE advancement.
And development overall in the college as well.
And development of college with Debbie Schroeder, et cetera. And we haven't come up with any of that yet. Giving scholarships, you know, those things cost a lot of money. I mean, that's a heavy, big donation. Whereas what I'm saying is the least expensive thing that would have true meaning for a student would be something along the lines of a you know, like I said, $1,000 comfort plane ticket, just $1,000 grant, you know, and what we would do with that is make an award. We'd have a competition to make an award, and hand out to students. So that's the sort of thing. We are looking for financial support, of course. We also need, and then there's a whole range. If anyone's interested in seeing a strategic plan, we have a strategic plan put together with a whole set of ideas, about 10 different initiatives and associated price tags. But I'm not going to bore you with that. I'm going to go on.
One question about the, like the type of projects Roger was describing and stuff. Are these kits that they're assembling when they get there, or is it also, you're creating new stuff to accommodate?
Well, very briefly, this is humanitarian engineering. The way the programs that are conducted is that the students are instructed. The constraint is you have to be able to build this in-country with in-country parts. If you're building a water filter, you got to build it with in-country parts because you want it to be replicable in-country, affordable in-country. If it breaks down, you want to be able to fix it in-country, and you want them, and that adds, not adds, it's a big part of the sustainability and ownership part of this thing. So, no, we're not, at least the three that I've been involved in, we are not bringing stuff down. We are building it up here as a prototype and then, implementing it down there with the parts that are available locally in the country.
Is there anything that you come across that turns out to be, I don't say revolutionary, but something that can then be turned into more of a mass-produced solution?
Oh, absolutely.
That can be...
Oh, there's no question about it. We're doing a filter, a family-size water filter that the students have been instructed, not by me, but, that we want this to be able to be built again and again and again. So we're building it very simply. That's actually version 2 of something we did last year in Ghana. With the parts, so if someone says, I want one of those, here's the method of building it. And it's a simple method, and it can be replicated quite easily.
Mark, in connection to your question, we've had one of our programs also try to emphasize what we call social business. So the idea is exactly. You're doing business, but there's two bottom lines. I'm going to make some money, but I'm going to impact people. And so this is really what you're talking about to achieve scale up. We don't have that many of our programs that are doing scale up because our students, because of their interests and so forth. Yeah. Okay. Just briefly, I want to talk about, we're reaching out to a lot of different people in the engineering disciplines. We're connected to all the engineering disciplines. College of Social Work, There's the development studies, international development, and then in public health, in the education college, also in business, a little bit for social business right here. There's a course over in Judy Tansky runs. We're connected to the Global Water Initiative, or now they call themselves the Global Water Institute because they were approved. The One Health Initiative in Ethiopia. And we have connections to ag sciences. These logos are people over here that fund us. Then you have some NGOs here in the middle, and we end up collaborating with a fair number of universities, actually. It's sort of easier. It's easy. You come in as Ohio State, they like that. They want to collaborate with you. They want to sign a memorandum of understanding, etc. We'll end up working together. We have 2 people associated with us: Greg Bixler, who runs design outreach, and then there's another gentleman running the Development Consulting International. So we have some small NGOs that are run by people that are associated with our center. I'm going to skip. I'm just going to say really quickly here. This is I don't want to steal from Mary because Mary's going to be talking about some of this. But this is some of the stuff that's going on in Columbus, Ohio, in a variety of projects. Okay, the stuff that goes on internationally. There's so many pictures that are sort of really fascinating. And I threw in several, and the list. I'll let you read it. You can read it faster than I can say it. I mean, the range of projects is really quite extensive, okay? Doing everything from cook stoves to solar, agriculture, shelter, computers, STEM education. So it's really quite a diversity of projects. And then for some, like you heard Roger say, there's continuous projects that continue more year to year. There's other projects that get done one-off 1 year, and then you don't do that project and you do something else, okay? So our objective, with the faculty's objective here is to try to say, how can we create a meaningful engineering design experience in country? Some of the key elements that Roger identified under these very difficult constraints. I mean, some of the things you think, you can get that over at Lowe's, or you can get that at the local Radio Shack or wherever, are just not available. You have to be sort of, you got to be good at tinkering and good at, being innovative.
Is there like an in-country liaison that works with the students in the pre-trip work?
Most of our trips, what we have, all of our trips that you saw there's an in-country partner that lives there, okay, and works with you. Now, some of those in-country partners are, they're doing things like helping you with logistics and making sure you're safe and you don't drink the bad water and all that kind of stuff. But other partners are doing what you say. They connect you to the right places to get parts or whatever else. It depends on each of the multiple cases. So on those, now just to emphasize, I said about 100 people travel, so that's about 10 persons per trip. There are about 10 trips. So it's more 100, really it's over 100 students that are traveling per year. Other comments? Okay, let's switch over to Mary. How do I do that here? Carol, yes. Thank you.
Oh, David Bradway is saying that's him by the plane.
Yes, it is. He is. That's right. David, can I point at you, David? Let me see. Yes, right there. Right, David? And who's this fine young woman right here to your right? I believe that.
Yep, David said in the middle.
Yeah. Yep,
Laura,
in the middle, exactly.
Laura with the back.
Right.
Also, Liza.
There?
Reed.
There?
Liza
right.
There?
is,
Is she here?
She joined us online.
Oh, good.
Hi, Liza.
Hi, Liza.
Was she involved in?
Not that I recall, but she could have been. Liza Reed? Was her name
Not involved.
Oh.
Tower?
Yeah.
Oh. Okay, sorry. Tell me how to do this.
So as we're transitioning, one of the things that kept on, the experience of building something and using the materials and limitations, the engineering project aspect, almost sounds like a co-op experience.
Yeah.
I don't know, Mary, if you can comment on that from.
Yeah, actually the
the first summer after my freshman year at Ohio State, I had gone in May with Kevin, and not to spoil the start of my talk, but I had gone in May with Kevin to Guatemala to find a partner, an in-country partner for one of these engineering service learning trips. And the nonprofit Mayan Families that was on that page of partners that we met with said that they were always looking for interns for the summer to help out, to start programs, just for manpower to do a lot of the things that they were doing. And to me, that seemed like the perfect way to spend my summer as an intern, setting up this engineering service trip by working there for 3 months, feet on the ground, getting familiar with the community and with our partner in country. So it was an internship experience. It wasn't the traditional engineering internship where you think, okay, well, I'll work at a big name electronics company and make a lot of money over my summer. It was a volunteer internship, but what I learned on that experience is something that I've definitely taken with me, maybe even more so than some of my engineering internship experiences.
But even if an employer was coming looking at someone and explained you worked on this project and solved all these limitations and overcame these challenges, it seems like
No, you're
carry a long
right. The employers are attracted to this because of that, and also because they're doing it in an international setting. You know, a company that wants their employees to be global, work internationally, recognizes the value of having, like Mary, live there for 2 months.
Yeah, I mean, it definitely was great material for interviews. For future co-ops, when they saw I already had work experience, I was already used to running projects in a work environment. It definitely helped out. Now as a senior, you know, employment opportunities and interviews are right there in the forefront of my mind.
I will flip for you.
Okay, perfect. Well, thank you. I am Mary Scher. I'm a senior in electrical engineering at Ohio State, specializing in power, and I am pursuing a humanitarian engineering minor as well. I am the current president of Engineers for Community Service, or ECOS, not to be confused with Engineering Career Services, ECS, which is why we made that acronym, because we get way too many emails of people looking for jobs. So I just want to give you an overview of what I'm going to talk about today so you know when to get bored and when you're ready to leave. I'll just hit 4 main points today. An introduction, just a background of me, why am I here talking to you, why do these programs matter, and then Engineers for Community Service, the student org that Kevin is our advisor, Roger is one of our faculty mentors. It's a student org that really brings together everything that quite a few engineers and quite a few electrical engineers want to do when they come to Ohio State. They want to design projects, engineering service projects that actually have a positive impact on the world. And then I will touch on some of our great achievements in ECOS and some of our goals for the future, also maybe worded as needs to achieve those goals. And that's going to lead us to our last point of how alumni can get involved right here in Columbus or from far away. So an introduction to me, why am I even here? Why am I an electrical engineer? Because growing up, I didn't know what I wanted to do. I just knew that I wanted to save the world. Doesn't every little kid want to be a superhero? And my father, Bob Scher, the name doesn't look familiar, you might not have received an email from me, but that is my last name, that's my dad, said, if you want to save a life, become a doctor. If you want to save the world, become an engineer. My dad knew that as an engineer, we see a problem and we immediately jump to, how can I solve this? What can I do? How do my skills, my knowledge, the technology out there lead to solutions to this? I think that engineers are kind of the perfect people to see inequality or see injustice and say, okay, this isn't an insurmountable problem. This is a technical problem. This is a social problem, and we are problem solvers as engineers. We can overcome these problems and save the world. So I am the youngest of 5 Ohio State Buckeyes, and 4 of us, our electrical engineers, came through this very department. And I'm the last one, graduating this spring, 2017, ending that long line of Scher ECE majors. Some background of my involvement here. I'm also besides being president of ECOS, I'm the 4-time co-social chair of IEEE undergrads, and I'm a member of Humanitarian Engineering Scholars, Eta Kappa Nu Electrical Engineering Honorary, Tau Beta Pi Engineering Honorary, Society of Women Engineers, Women in Engineering, Betty Lisa's STEM Education Outreach Program, and just for like a little bit of flair, I'm part of the OSU Swing Dance Club. Not all my clubs have
$50
engineers.
if someone can name an organization she's not involved
I think I hit most of the engineering ones. So to move right along to Engineers for Community Service, that is the main reason I'm here. That is the main reason I am here, still passionate in my degree, still passionate at Ohio State, because my first semester at Ohio State, I jumped in, I got involved as a project leader for Engineers for Community Service. We were setting up a database for a food pantry so that they could keep stock of donations for one of their large service events. And through leading that service project, I got to know Professor Passino. And Professor Passino is one of those people who will ask you when he first meets you, what do you want to do with your life? And for me, my answer was, I want to move to Latin America and I want to work as an engineer there. And he said, you want to go to Guatemala? Maybe this May? So we had that conversation probably around February time. So he moved pretty quickly. And that trip ended up changing the course of my entire college career. And that course, or that trip, is why I'm standing here today. So some background for ECOS in general as a group. It was founded in 2004, as Kevin mentioned, and has had a slew of either one-time projects or continuing annual projects. Right now we have 7 active local project teams, and as Kevin mentioned, we are partners with numerous international projects out there. ECOS started a lot of these international projects or laid some of the groundwork, the organization and the logistics for them, though a lot of these become absorbed by the college or by the university as study abroad trips, because for healthcare or for safety or for traveling, it makes a lot of sense to have the university associated with each of these trips. But to talk a little more about my introduction to ECOS before we move on to...
Sorry?
That's quite all right. You can leave those great pictures up there. Before we move on to the projects we do in Columbus. As I alluded to before, Kevin and I went on a week-long service trip to Guatemala in May 2014. And part of that trip was to assess what partners were out there and what projects were available to OSU students looking to do engineering service learning in that country. So through the course of 7 or 8 days, we met with 7 or 8 nonprofits across all of Guatemala. And when we reached Mind Families on one of our last days, it was quite apparent that this organization was one of the best fits for an engineering service trip to begin. So though I had planned to take classes that summer, and though I had planned to do research with Professor Passino, when Mind Families said, hey, well, if you're not doing anything this summer, we are always looking for interns to help develop our programs. And we heard of some of the work that Professor Anderson is doing with outreach and teaching science and computer classes or STEM experiments to kids. And we'd love to have something like that started in our preschool program. I just couldn't turn them down. I turned to Kevin. I had to tell him, hey, maybe I do this research instead. And luckily he let me go. So I ended up spending the summer of 2014 working at Mind Families piloting a STEM education program. It started in their preschools, but was so successful off the bat that they asked if I would teach to junior high students as well. So some junior high students from schools a few towns over would walk over mountains, essentially, in this very mountainous region to come to build these experiments and to use their hands and learn these scientific concepts. And part of what was so appealing about this program was Betty Lisa and Clayton Greenbaum, one of her students in the STEM Education Outreach Program, and I all worked to develop nonverbal instructions for these experiments. Because though being fluent in Spanish definitely helped living in Guatemala, there are over 20 indigenous languages spoken throughout the country. So many of the students that I was teaching did not speak any Spanish or any English. They spoke Cachiquel, which is one of these indigenous languages. And when they get to school and all of the instruction of all of their subjects is in Spanish, a language that they do not know a lick of, it can be discouraging, and that leads to high dropout rates for these students from very young ages. As soon as they're old enough to start going to work, they leave school because they're not feeling that they're getting anything out of it, and it's not interesting them, and they're not excelling in all of their subjects because of this language barrier. So our research for the summer was researching if these nonverbal instructions were something that could introduce subjects to students without them getting discouraged by a language barrier. They could build something and have it work, or they could understand a scientific concept without Spanish being the barrier to them excelling in school. So that was the idea of the project initially, and it worked so well this first summer that my family's actually hired a full-time employee to carry on this program after I returned to Ohio State for my sophomore year. And Kevin and I worked with Humanitarian Engineering Scholars to set up an annual trip to go back to Mayan families and do engineering service projects that we had touched on before. They researched the design of cook stoves, of solar lights, and they also go back and send me pictures of my students, check in and say, oh, look, this kid's still in school. They're already in 3rd grade or 4th grade. So it's been very rewarding to be involved in that way. And that kind of launched me into this path down leading ECOS. I became Vice President of International Projects, looking at international opportunities for engineering service. And this year I am ECOS President. So this year, as I said, we have 7 active local projects, as well as these international projects. And some of them are highlighted here. We have our Downhill Derby project where we work with kids at Gladden Community House, where they try to master the concepts of aerodynamics and really just learn a lot about power tools. But it's a great program for students and children to connect and to build these downhill derby cars together at a community home. We also have our Westminster Thurber computer classes, where students go once a week to a nursing home or a retirement community to answer any technology-related questions. We get a lot about printers as well as iPads. But it's been a great program for the students and for the residents. I found when I was project leader for that project that it was the best thing to do after a horrible midterm in one of my engineering classes. Go to the nursing home and have them ask me their most technical questions. And man, did I feel brilliant when their question was, what's the difference between email and the internet? I was like, I got this. I was born for this. So that project is ongoing and one of our most successful projects every year. We also have one of our newer projects, the Humanitarian Engineering Scholars Homeless Shelter Design Project, which was taken, was started by a student who was in HES. And after she sort of graduated that program, which is just 2 years, she recognized the connection between Engineers for Community Service and HES, and she wanted to foster that connection and have students who were involved in engineering service learning in their freshman and sophomore years, provide them with an outlet to continue that service learning their upperclassmen years. So Emily Reed, who actually just won an award through the university and will be recognized at the OSU Civic Engagement Banquet next week for the Benjamin Banneker Poverty Award in Housing, because of her idea with this project, starting a team to develop a low-cost and low-weight shelter for the homeless population in Columbus that they can carry around with them for the nights that they can't make it into a permanent homeless shelter, which often get crowded, especially as the weather gets worse and worse. So part of her project is going to homeless shelters and interviewing people who are homeless in the Columbus area and asking them for the design constraints, asking them what their needs are, and what ideally they would want to see in a shelter that they could have with them when they couldn't make it into the permanent homeless shelter. So this is the second year of that project, and as you can see, they've tested out designs. They plan to bring that to the homeless shelter this semester or next, and try to re-interview their original population and see what this final product design looks like to the community who would be using it, and what tweaks and what suggestions and what different desires they would have seeing a constructed product. And I'm going to touch on this project quite a bit. We also have our wheelchair ramps project, which is our longest running project. Every year or sometimes once a semester, we build a wheelchair ramp for a resident in the Columbus community who is in need of a ramp. They are identified by some partners that we have with the OSU Medical Center as someone who either is in a condition where they're about to require a wheelchair ramp, or they will require a wheelchair ramp outside their home. And Roger Zwanzak has been a wonderful faculty mentor for this project for these 11 years that it's been running. We've built 18 ramps in the city of Columbus, and this is just one of many that you might see driving around town. All of these ramps are designed by students, built to code, so that they are lasting fixtures on these homes, so that these people can get continual use out of these ramps and have mobility inside and outside of their home. So just to touch on some achievements, some wow numbers for some of these projects. As I said, 18 ramps in the city of Columbus in 11 years is just an exceptional number. It blows my mind to think of it, that many ramps and that many lives have been touched through this project. A fun one we like to throw in is that over 60 computer questions are answered each semester at Westminster. We originally had 60 residents because we count each question that we answer at the community homes, but students were clear to point out that many of the residents are repeat customers. Sometimes you'll get the same person coming every week. Sometimes it's a different question every time. Sometimes it's the same question every time, but we put 60 plus computer questions are answered each semester at Westminster, with about 10 to 15 students going each week. And 50 plus engineering students are engaged each semester in one of these many project teams. Each team will have anywhere between 7 and 10 students involved, depending on how big the project is, how many people or volunteers it can engage. So right now we have quite a few students involved. So achievements and goals, this falls under all of those things. Our faculty mentor, Roger Zwanzak, has served us faithfully for 11 years, helping this wheelchair ramps team really get off the ground. And having a faculty mentor for these projects is so important when there's knowledge that has to be handed down year to year, and students graduate and move on to great jobs, especially ECE students. They're traveling to California and New York, getting their tech jobs, and then they're a little harder to reach. So it's so important to have faculty involved in these projects so that there's a smooth transition of leadership. So he has served us faithfully these 11 years, and we are celebrating this year. He's going out with a bang, his retirement as our faculty mentor. Now this is contingent on all of you. This is contingent on if this project can continue without him, because these past 11 years, Roger has not only put in so much time going every Sunday to work on these ramps, he's also allowed us to use his personal power tools to construct these ramps, and of course his wealth of knowledge.
And don't forget my car, too.
Don't forget his car. That's a very important point, especially for a student. So as far as goals go, our goal this year as Engineers for Community Service is to gather up the funds or the tools or both to continue this project without continuing to rely on Roger's personal supply of power tools. So that transitions straight into how alumni can get involved. Naturally, as Kevin said, through donations, that is one of the #1 ways people from a distance can reach our student orgs, reach our students, and touch the lives of people in the Columbus community. We are looking to gather over $1,000 worth of power tools to keep this project going. And our goal is to gather that within the next year so that we do not keep dragging Roger back year after year, asking him, oh, but we don't have a circular saw yet. Or, well, if we could just have your power drill and your minivan. So, donations, of course, are a great way for alumni to be involved. But we also have exciting hands-on events for any alumni or friends of the university who happen to live in the Columbus area. We are planning an alumni wheelchair ramp build event. It will be a fun night where you can come out. The students who are there, who've been building these ramps semester after semester, can teach you anything you need to know if you are like me and were unfamiliar with power tools coming out to your first wheelchair ramp build. The catch is that all the tools would be brought by alumni and left to Engineers for Community Service. So as much work can get done as you bring tools. So we would, of course, have our borrowed supply of tools present so that we could do meaningful and productive work on the ramp. But for any alumni who happen to have, you know, that drill or that circular saw that you bought to build that deck that you finished years and years ago and that you haven't touched for a long time, or that's gathering dust, or maybe you have been looking at this great deal at Lowe's and going, well, I don't need a power drill, but it is on sale. This would be a great opportunity to buy it, get the chance to use it once, and then donate it to a great cause. So the date is to be determined because it's going to be dependent on you guys. We go out just about every Sunday once we get a ramp started. So we will send out when the ramp build has begun to the alumni in the same way that you've heard about this meetup. And we'll gather back which of the build dates that we have scheduled for this semester or next semester is ideal for the alumni to come out and call that one the alumni build event. So we will be reaching out to you with future emails, and of course this build event would be coming up and you could put it on your calendar, but any day before that point you could purchase power tools, you could send a donation, you could support ECOS in one of those many ways, because it's great alumni like you, it's great donors, and it's great engineers who keep this club and keep humanitarian engineering at Ohio State going. So we just thank you all for coming out tonight. And if you have any more questions about ways to get involved, about future events we might have for alumni, or just any other questions related to humanitarian engineering at Ohio State, I am available this evening or via email or phone. So questions, reach out to us, learn more about ECOS on our website, and thank you so much for having us here tonight.
So how long does it take you to build a ramp?
Great question. Roger.
It takes about 6 weeks. It might be a little bit longer, it could be a little shorter, depending on the size of the ramp. We usually have, I mean, students-wise, we have 5, 6 show up each session, and so 6 weeks.
So is it? So are you doing as many ramps as you'd like, or is there opportunities for you to expand, or is it basically you just build a ramp and then you start the next ramp right after?
The pattern has been over the years, one in the fall, one in the spring. If you do the math, 11 years, 18 ramps, it's a little less than 2 ramps a year.
Okay.
Interesting. Yeah. I have 2 questions. First one is, I'm interested from a perspective of yourself and the students you've worked with, the fact that you're really in a lot of ways going outside of your comfort zone. I mean, when I was here, I didn't visit any nursing homes. I don't think, well, we didn't have anything like this back when I was in the ECE program, but just going and spending time with people that are retired or going to a different country and seeing people that are disadvantaged, did that really help to keep you a little more, and I would think it would have to, a little more grounded and centered? And you might have a long day and, like you said, a bad midterm or something, but that just really puts things in perspective. Because I know it's easy to get kind of cloistered especially once you get into your program. So I didn't know if you found that.
I have definitely, absolutely found that I think students, even if they don't recognize it, need these sorts of trips and activities just to maintain sanity, because the walls of Caldwell look all too familiar after nights and nights in the lab, and having one night a week, only one, where I go, okay, well, tonight I'm just going out for an hour to the nursing home, spending an hour there. It's important to have that break, and in that break to feel like I'm still being productive, I'm still doing valuable work, and I'm still being a little technical. So I think that these projects are really important for students, because it's for ECE students especially, who are always studying, always working, staying very active. Sometimes it's hard to take a break from schoolwork when you feel it's so important, to do something that you feel might be less important, though many of us fall to the Netflix category way too often. I think it's so important to have pastimes and have breaks scheduled in that actually are productive and valuable. And these sorts of things do lift your spirits a whole lot, so that you can go back afterwards at 8 or 9 p.m. after you've been tutoring at the nursing home and hit the studying again.
So we got Liza and David are commenting about putting this up on our alumni website, when you have a date, call for donations, stuff like that, and also reaching out to more of the other engineering societies and departments. So obviously you're represented by all engineering disciplines.
Yes. Yeah. So it's amazing, actually. The ECE department is well represented. Both our vice presidents and myself are electrical engineering students.
That doesn't surprise a lot.
As well as a good handful of our leaders. So I think it says a lot about the ECE department, which is why, of course, we're reaching out to you first. But ECOS is a multidisciplinary club, so definitely going through other engineering disciplines within the college is going to be really important as well.
Have you guys thought about doing some type of crowdsourcing donations, kind of like how Lise did with the STEM?
Yeah, we actually just started this semester doing the exact Buckeye Funder that Lisa sent us the details on what to do. Yeah.
So you can go ahead and get that established.
Exactly.
That would be a perfect vehicle for alumni.
Right.
We weren't allowed to contact the alumni.
Well, we did.
Oh, you did? Okay.
Did you? I don't know.
Well, I'll just send it to you, and you'll know.
Maybe. You weren't allowed to contact and let them.
I had to run the list of people through development, and they had to check because they didn't want us to contact anyone who was already being hit up for something else.
It's more of a broad thing. You go online and you go through those channels.
$50. I mean,
I want to make one quick remark. This computer education at the retirement community. So the way that started, for the alumni's sake here, you may remember Professor Kurt Levis. Okay, he is at that community. He came to ECOS when ECOS formed and asked for help, and he's still there. So I don't know if any of you have had him as a professor, but Kurt Levis.
It was amazing. He was our point of contact at the Westminster, and I'd been working with him through email and seeing him in person every Wednesday night. And then I thought about his name, and I pulled out my Electrical Engineering 3010, so that's a radar book, and I looked at it and I said, "Is this your name? Are you the author of my textbook that I'm studying in school?" He was like, yeah, that's me. Like, can you help me with my I'm like, I don't think that's what this hour is for.
I'll answer a question for you if you answer a question for me.
Yeah, exactly. But it's been
Kurt
so...
was doing the training himself and decided he could use some help. So.
Yeah, exactly. Kurt is one of those sharp residents who was honestly getting overwhelmed by the number of people coming to him with computer questions. And so it's been great working with him and meeting a lot of these people who, a lot of them are from Columbus. They know Ohio State, they know the Columbus community. So just hearing their stories and getting connected as OSU students to sometimes OSU alumni there is really incredible.
So some of the other ECOS projects, how do you guys get that funded? Do you have sponsors, or is it just students? Is it just elbow grease at that point?
So a lot of it is grants. One of our projects, the bike design project, creates bikes for children who are handicapped, who need seats or sizing to be altered. So that actually won a Buckeye Soup grant last year. So that's one of the ways we get funded. A lot of it is through Battelle or Ford, some of the larger grants in Columbus. Though being a multidisciplinary club, it's sometimes hard to get corporate sponsorship just because when corporate sponsors come in, a lot of their goal is to recruit, and it's easier to recruit a specific ECE club or Chemi club than to recruit a club that invites all engineers to participate. But if the ECE Alumni Association was looking to sponsor a club, we've got one to suggest. But yes.
It's interesting because I work at a huge multinational engineering corporation, and it's amazing how many times we've been able to get the job done because I happen to have like a Leatherman tool and 4 tie wraps in my backpack.
Mm-hmm.
And I think it's really interesting that you're going out there to a lot of times to a country you don't know about your supplies or anything, and you need to get the job done. So, in all the different things that you've been involved with, what is your, I guess, the best way to put it, what's your proudest MacGyver moment? Where you really came through with something that was, you took what you had, and we need to get this job done, and you used what you had and were able to complete the task.
Does she know who MacGyver is?
Of course I do. Oh, I could probably
Well, they just
sing
put
the
him on
music
TV
of the
again.
theme
Yeah,
song.
did they? He's on again.
Oh, wow. Oh, I know old MacGyver. I mean, my oldest brother was class in 1994 from OSU, so I've got some history here. So I guess, I don't know if it's necessarily a pull out of my bag all my tricks MacGyver moment, but I did have a little bit of a aha optimization moment with actually one of the projects, the STEM experiments that I brought down to Guatemala. So Betty Lisa provided us with a lot of the materials to get started with coil and with batteries for some of those. But naturally, I couldn't bring everything in my suitcase. So she said, okay, when you get down there, you just got to start hunting for cardboard or styrofoam or different things that we needed for these projects. And one of the projects, the DC motor, it in the original design had a styrofoam base and then paper clips and wires connecting it to a battery. And the DC motor, if you put a magnet there, will spin when you connect the battery. There's some shaving of painted wire involved as well. But I was sitting at my desk at work at Mayan Families, the nonprofit, and I was writing out my lesson plans. I would write through them in Spanish so that if teachers had any questions, I could answer them before I went through how we would go through the lesson. And I was trying to think of where I would possibly find styrofoam. And I was playing with the materials that I already had on my desk, which was the magnet and the battery, the paper clips, and the coil. And I, just playing with it on my desk, realized that we could get rid of the styrofoam base altogether if we just set the battery right on top of the magnet and use the magnet as the base, and it would still stand up perfectly on a kid's desk. And it got rid of a material that, quite frankly, was hard to find in the communities where we were working. So that sort of moment, it felt like a true engineering moment, where I said, we cut out this thing we didn't need that was hard to find, that was honestly an expensive or difficult piece to get, and we simplified this design to make it even better for the people we're serving and for us who are coming up with these designs and teaching kids and giving them to kids in Columbus as well. So I think probably that moment.
And it was easier to build, and you got rid of the wires, and the paper clip just stuck to the magnet instead of being stuck in a styrofoam. And your design is much better. That's the one we use now.
Well, thanks to Professor Anderson. She sent me all these materials, and it was just throwing magnets and batteries at each other on a desk that made it all come together. So probably that moment.
So Betty Lise, how does your effort fit into all of this?
Anybody, like when Mary went to Guatemala, she said, oh, I'm going to be teaching STEM. So I said, okay, great, here's all these projects, go do our work for us. And she goes, okay, I think I'll do it in Lion. Yeah. What was the name of that language you learned?
Kachiko.
Yeah, she
I only
learned
know a few phrases, mostly like, be careful, don't stick that up your nose, like normal.
Do you draw your volunteers from the same?
There are some people in common. I draw my volunteers mostly from ECE. I go to Kevin's ECE ethics class and pitch it there every year. So I get mostly ECE students, but word travels around and other people are welcome to join in. I guess I don't ask them, are you with Yukos? But I imagine a bunch of them are.
Then a question for Kevin. So you have the humanitarian engineering minor. Are there certain career paths that some of your students are taking because with a humanitarian engineering slant, or is it just kind of a?
Okay, there are some students that have gone this route and made a career of it. And so far, ones that come to mind, I think David might know Katie Kinstead, who I believe recently just got back from Haiti. She's worked with an NGO down there called Medway. Then there was Eric Reynolds, who was a mechanical engineering student who worked at MIT D-Lab, which is their version of what we're doing. He worked with them for quite a few years, and now he's just now going, like, quit, and he's going to get his PhD at Stanford. So, I believe it's Stanford. So we have a few students that make a career of it. I think more of what's happening with our output of our students that are in the minor or whatever is there's a few things. First of all, it's helping people get a job for the reasons you mentioned before. It's helping them get a global experience. I think we're seeing more and more that companies have a global reach. They have the manufacturing facility in Honduras and whatever, and so this gives them an experience that the companies like. But I think that the most common thing is the sort of weekend warrior. They got their engineering job at wherever, AEP or wherever, and they're going out on either nights or the weekend or for their vacation time, and they're doing this sort of work, field work, and work, things like that. I think that's where our biggest bang for the buck actually is, putting people in careers in this area. It's happened a little bit, but not a lot. It's mostly the weekend and vacation person.
David mentioned Jorge.
Yeah, Jorge Finke, he's a professor down at Universidad Pontificia Javeriana in Cali, Colombia. He's a professor in this area. He actually studies what he feels is the most important humanitarian subject for Colombia, and that's corruption. Fighting corruption with lots of there. Seriously. That's what he does in his research. I just spent time with him in August in Paraguay.
Wow. Now kind of what a lot of departments in DC do. Fight corruption with electrical engineering.
Yeah, that we do have some of those.
Yeah.
Have you thought about combining some of the humanitarian stuff with the STEM? I volunteer and am a part of a big STEM. Roundsburg has a fab lab, has multiple fab labs and stuff like that. We go, they have tinker spaces in their elementary the whole way up to main fab labs. And that was one of the problems that, they have problems getting problems for the kids to solve. That's where a lot of it comes in from, like me that work in industry or work and say, hey, here's this problem, can you have it? And they have other companies and stuff come in, but I know that's one of their big things because the way they have it structured is that they're a problem-based education. So they don't just teach electronics, they say, here's a problem, how do you fix it with these requirements or with this material or with these guidelines and stuff like that. I know their seniors all have a capstone project and stuff like that. It usually comes from industry, and again, I've been around to help. One was a brace that actually massaged the leg so you didn't get blood clots and stuff like that. They had to come up with ways to do that and stuff like that. So I know one of the problems that that a lot of the schools have is getting these problems, because most of them are teachers, so they don't have that experience, they don't have that, so the humanitarian aspect and that problem solving aspect, I mean, what you're asking your students to do going to Honduras and solving those problems, we're trying to do that same thing with students in high school and the resources they have in STEM education. So is there a way that
Jim must be.
I'd love to be, I'd love to be a part of seeing that happen, really, because it's something that I really, it was neat seeing these kids doing stuff that it was like, wow, I was in shop class, but I wasn't designing a leg brace that also massaged and, and they were asking me questions and stuff like that, and I could give them the help that I had, but, helping them solve those problems. I know there was some ecology stuff with like animals and making a mouse trap that a mouse could actually live in for more than, so it was a trap that kept them alive, not killed them. There was some turtle stuff going on that came, again, problems that came from the public. I know they have some hospital stuff with Mount Carmel that comes in. They did a fair for Mount Carmel to map out students like exercise and their movement and all that stuff. So there's some, but not nearly as much as what I'm seeing here.
I definitely see potential. I know Professor Anderson with the STEM experiments goes to schools all around Columbus with these experiments that students build themselves. And there's also a component of ECOS Ask a Buckeye that does tutoring for middle school through high school for STEM subjects. So with those relationships, I think if there were projects that students would be interested in solving, or projects that that these college students would be interested in having the high school students work on and solve, I definitely think there's an outlet for that.
And I have an idea, it just came up this week, so I've been spending a lot of time with AP engineers because they want to get involved in going to schools, and they say, well, how come you don't have any projects related to energy? So, because I don't have time, that's why. And one idea was to create a generator that there was a water wheel that would turn the generator, because kids love to play with water, so they can pour water on it. And so is that something that your kids could like take and run with and create some kind of educational tool?
Yeah.
There's one example that just came up today, so I'm thinking there could be others.
Yeah, absolutely.
Okay, I'll give you my card.
Yeah, and one of the things, we've gotten from Betty Lise before, and we talked a little bit about this week in emails, new projects.
Yeah.
You're always looking for new ideas that can be used to communicate, solve it. And someone, Liza, online forwarded us the link to the TED Talks and stuff of the guy who's creating the $1 microscope.
Yeah.
Yeah.
Oh man, I'm
Really
so jealous.
cool. And so, whether there's opportunities to have, create $1, foldoscopes and to distribute and everything, or to go to schools and teach kids how to do it.
I heard about those like a year ago, and I tried to get them, but they weren't available then. But now they're famous, so maybe now they're available.
Yeah. But and definitely that's stuff that I would like to see alumni coming helping out with.
But it takes a significant amount of time to take an idea and develop it into a robust, kid-proof project that actually teaches something and they get to do something. And so that's our limiting factor. So I have groups of our students develop those projects, and if high school students could do it, how cool is that?
My son went through the Project Lead the Way STEM experience in Hunter Davidson, and that was wonderful. And they actually have a design and development project for their senior year where they have to come up with a new invention or modification. They have to go through all those concepts.
Yeah, and Brownsburg is a Project Lead the Way school. The only problem with that is, again, it's limiting. You have to go to them to get the education to do it. Like the one teacher that was certified through the whole program actually left and moved to Cincinnati, so they're back to square one of getting the people educated to go through it. And then even then, some of the projects, some of the stuff that came with it is like, here's a $90 or $93 Arduino kit from, and it was like, well, I can go to Micro Center and get the same kit for $30, and it's like, well, that's going to be a lot more, but their whole thing is geared towards this one stuff. Like another one would be they used to use SolidWorks, they use Inventor, but we're pushing towards Fusion 360 because they have CNC, they have MCO CNC mills and lathes there that I'm helping them get up and running to be like their shop bot, where they can just take something and take it in, do the CAM for it. We didn't have that for this. Well, Fusion, once we get it going, can do every machine there. So their output for their laser cutter, their output for their shop bot, their output for the 3D printer, their output for the, so we can teach a kid one program and it'll go, no matter what, they can see the different modalities of going from a 3D something like a 3D printer to a laser cutter and all that type of stuff. So, but that's the limiting factor that I've seen with like Project Lead the way.
My son's school hired a couple engineers to run the program, so and they solved a lot of those problems, and it's very well run.
Yes.
So.
Okay, any more questions?
Okay, thank you.
Yeah, so do you have this, so ECOS needs a bunch of tools. I heard power tool, I heard drill.
Yeah.
So I'm worried that you're gonna get like 10 circular saws and 10 power tools.
That's a great
Are you registered at like Home Depot or something, that, you know, like the Bride thing? Something
That's a
where
good idea.
we
I
can
never
go and
thought of
say, I wanna give, what do you need? You know, what's in my price range?
That
Oh,
is great.
screwdriver.
So we have a list of tools that we are looking to obtain, so we could go to Lowe's, or I think Lowe's is our partnership store.
Well, Lowe's has been providing all the materials for us for almost the entire time we've been doing wheelchair ramps. So
Wow.
we put in not me, but one of the students wrote a little blurb, and they, at least Silver Drive gives us 10%.
Uh-huh,
So we get 10%,
uh-huh.
we get tax-free voice, and that would therefore be the place to buy the power
Yeah, there you
tools
go.
or buy any of the
Sure.
tools.
They must have the gift registry.
For alumni, is there a way to find out, do we have any former ECE folks that work for Milwaukee, Ryobi, DeWalt, any of these companies?
Oh, it has to be DeWalt.
The colors, I like the colors.
See, I'm a Bosch guy
Nice.
myself. Milwaukee, no.
DeWalt beats all these.
But you want to get something that's a little better.
I actually know Black and Decker is definitely an alumni because he was the one that gave the money, I think, for the
Yeah.
mechanical engineering.
Peter Scott,
Oh.
former chairman of Black and Decker. Scott Lab is named after him.
You might have
Anything
a
for free, I mean, I've always
That's
said.
the way.
Yeah, but you probably don't ask the guy for a drill.
Go
Go a little bigger.
We're gonna call him up and ask for a drill.
Liza was mentioning about wanting to get on so she could speak, and we're trying to realize.
One moment.
She said it's okay. She was thinking about this civic engagement stuff. We'll try.
It's under here somewhere.
Yeah, the project leader who is running the Civic Engagement Award is also an ECE student. So Emily Reed is a senior in our department, and she's been doing great things in the area of housing.
Can she talk now?
Can you speak now, Liza? You might have to activate a microphone on your computer.
Maybe not.
No.
That's not a big thing.
Well, we're trying to figure it out. I know we're out of the scheduled time here, but this is exactly what I wanted as far as introduction and background. I think it was really good. Like I said before, I didn't know any of the stuff going on. So as alumni, it's great information. Once again, another thing that's very proud of to see offered and available to our students. And I'm sure spreading a lot of goodwill with Ohio State, college engineering department throughout the world. So that's fantastic stuff. I think that we have a lot of material to work with here. So just now we have to find the right way to connect with with alumni.
Yeah,
I mean,
I think a lot of us, our gears are turning about what we can do.
Yeah. Yeah, and I think one of the nice things is, we've been talking about getting people more engaged and everything, but now that we actually have maybe something to sink our teeth into and use as a platform, because I mean, how many different donors did you have for your STEM stuff?
Oh, 40 something?
Yeah, I don't remember either.
Yeah.
That page is still up, so.
Yeah. People are still donating.
Yeah.
Okay. Yeah, and Liza mentioned that one of the purposes of the ECE Alumni Society is to, give back and, community service and that type of activity with alumni. So, yeah, we have newsletters going to go out and could even highlight this type of activity, how alumni can help out. So, that's great. Appreciate you guys coming and taking the time.
Thank you guys so much.
Yeah, thanks for having us.
Thank you.
Go ahead and stop recording.
All right.
Yeah.
Thanks a lot. Nice job.
Thank you so
I didn't
much.
realize you were seeing Kurt over there.
Yeah.